Hello friends, welcome to GSR ChemTube channel. Here we're going to see about matter chapter in that physical classification of matter. First let us see what is the nature of matter. Matter is anything that has mass and occupies space and can be perceived by our senses. Matter exists in many forms. Here you can see some of the forms of matter. As we look at our own surroundings, we see a large variety of things with different shapes, sizes and textures. Everything in this universe is made up of material which scientists have named as matter. The air we breathe, the food we eat, stones, clouds, stars, plants, animals, even a small drop of water or a particle of sand, each thing is matter. Now let us see the classification of this matter. As there are so many kinds of matter, a scientific study of matter becomes easier if we classify the matter based on some characteristics. Matter can be classified based on two factors. One is physical classification, the other one is chemical classification. So in this way, if we classify the matter based upon the physical properties, it can be classified into five types. If the same is done in the chemical classification, the matter can be classified into two types, pure and impure substances. Now let us see here the physical classification. Matter is composed of extremely small particles. Based on the arrangement of these particles, matter is mainly divided into three types. They are solids, liquids, and gases. Here we see about solids. In solids, the molecules are closely packed up, means they are tightly packed. Their positions are almost fixed. For example, if we see these all are examples of solids. In these, all the molecules are tightly packed one to another. Now let us see the general properties of these solids. Solids have fixed shape and they have fixed volume also. Generally, solids cannot be compressed. There is it. That means a solid does not flow. A solid expands very little on being heated. Solids have very less interparticular spaces and very high interparticular attractions. Now let us say about liquids. In liquids, the molecules are not packed as closely as in solids. For example, here some examples for liquids are mentioned: water, juices, milk, oil, petrol. These all come under examples of liquids. Now let us see the general properties of liquids. A liquid has no fixed shape. It takes the shape of the container in which it is kept. A liquid can be compressed only to a small extent. Liquids can flow. A liquid expands or contracts more than the solids. Of course, they expand or contract a little, but it is a little higher than solids. Liquids have more interparticular spaces and less interparticular attraction compared to solids. Now let us say about gases. In gases, the molecules are at a greater distance from one another as compared to solids and liquids. Here, these balloons contain gas. General properties of gases, let us see now. A gas has neither a fixed volume nor a fixed shape. It assumes the volume and shape of the container. Gases can be compressed to a much larger extent than the solids and liquids. A gas expands to a greater extent on being heated. Gases freely mix with one another that we call as generally diffusion. Gases have very large interparticular spaces and negligible interparticular attractions. Next, fourth state of matter is plasma state. Plasma is similar to the gaseous state. Plasma is made by heating a gas. atoms and molecules in the gas lose all electrons and form ions and electrons to coexist. This state is called plasma state. So the plasma is produced in sun and stars because of very high temperature in them. The sun and stars glow because of the presence of plasma in them. So what happens in sun and star? They have very high temperature. Because of the very high temperature, the gas molecules in the stars and sun, they ionize and form ions and electrons to coexist. That state we call as plasma state. On Earth, plasma is naturally occurring in flames, lightning, the northern southern lights, and these all contain plasma. Next, fifth state of matter, that is Bose-Einstein condensate, which is also called as simply BEC. In 1924, Albert Einstein and Satyendranath Bose predicted the Bose-Einstein condensate, which is referred as the fifth state of matter. A Bose-Einstein condensate is a gaseous superfluid phase formed by atoms cooled to temperatures very near to absolute zero. So when a gas, if it is cooled to absolute zero temperatures nearby, then it comes into BEC or Bose-Einstein condensate state. Supercooled fluid we call it as. A Bose-Einstein condensate is a state of matter of a dilute gas or bosons cooled to temperatures very close to absolute zero, that is nearly 0 kelvins or minus 273 degrees Celsius. Under such conditions, a large fraction of the atoms collapse into lowest quantum state, producing a superfluid that we are calling as Bose-Einstein condensate. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates.